Good. So I'm here to speak about Microsoft Data Platform Capacity Planning. And as Devon told, my name is Jani Savolainen, and I'm founder and CDO of SQL Governor Company. And there you can see my email if you have any issues rising after or during the presentation. I gladly try to help you as I can. So okay, the agenda. First of all, I'm going to going through the challenges in traditional capacity planning. What are the typical use case scenarios, the problems there needs to be taken care of. Then about reasons for migration and how the capacity planning affects the system performance. Then few things about how to prepare for migration. I'm going through the importance of diagnostics and performance optimization as a part of the migration project, and then also what to take in account in Azure IaaS transition in this particular case. Then I'm going to show a couple of demo cases with our cool SQL Governor software. So first of all, planning and consolidation of SQL Server instances from multiple servers into a single virtual machine in Azure Cloud. And another demo case that is planning and consolidation of multiple SQL servers into a host pool in on-premise virtual platform. And then I'm going to show you how to calculate the potential of your environment's cost savings when using consolidation methods as described here. Okay. Then I'm going through these challenges in traditional capacity planning and how to tackle them. So one of the typical challenges in traditional capacity planning is the lack of visibility to all the servers, instances, and databases. You may have 20 or more years of time having different kind of database management systems, servers there, and new server appears here and there can be company mergers and things like that, and every now and then a new software appears and you need new databases, and you're not sure that which databases are used when, and when certain hardware is renewed, when the service packs are being applied for the service and things like that. It can be really lots of things to maintain there and keep on track. So that would be one of those challenges. And there is of course software for keeping up such a repository of all that. Then one thing would be a lack of proper monitoring software. So what comes to capacity planning, it's quite important to know that which are the baselines of your servers, instances, and databases, and different kind of failover clustered instances, and always on availability group setups that you're having. So this is also important thing, that you have all the performance counter data for those objects from a long period of time with the great enough granularity to be able to understand that what is the capacity needs for your future platform. Then another thing that you would need is to if you have a lack of detail in your monitoring data. So let's say that if you have, for example, 1 year, 2 years, or even like 5 years of monitoring data, but the granularity of the monitoring data is on 1 day level, or even like a weekly or monthly level. So you really don't get then the behavioral characteristics of the time series over time, because typically those big changes are on 1 hour level. So this is also important thing, that you should get at least let's say 1 to 4 hours granularity in your long-term data to be able to make the calculations in terms of capacity utilization. Then some other things that you should know is the ability to understand how trend affects to time series. This is very important because you understand that if there is uptrending or downtrending usage on some storage component, database, data file, or on a CPU consumption side, there is definitely a upcurving trend. It has to be taken in count in capacity planning, especially when investing into a physical hardware on a target system. Also, in some cases, the virtualized environment, but it's not as important as with physical hardware in such case. Then also you should have ability to diagnose problematical servers, instances, and databases, and you should have ability to understand the difference in between the performance of the servers. So if we are going to performance of the servers, I mean that certain servers have a certain benchmark in terms of CPU computational power, and that's the most expensive component basically, because it takes in account also the licensing on enterprise and standard edition of SQL Server and so forth. So it's crucial to understand for that software that they're using on capacity planning, that what's the benchmark of the particular source server and that hypothetical target server you are aiming to. And as I said, the ability to diagnose problematical servers, instances, and databases. This is because otherwise you may fall in trouble if you are just taking the workloads as they are and put them on new servers. It's a good idea always to make a proper health check for those areas before applying to a bigger capacity planning project. And then one of the challenges is that how to estimate the potential costs and savings. That's also important thing to go through. And because especially when consolidating, you may end up having a great savings in your total project. So that's why it's good to understand are those savings like in which ballpark we are moving there if we are going to do that properly. And then one of the things is also that how to consolidate servers, instances, and databases in most efficient way. And as I told, there is different methods for that. And for example, our SQL Governor software has IPR on that, where we use machine learning to make the most efficient consolidation on restacking the instances on a target platform in a way that the minimum CPU computational power and RAM usage is being needed on a target platform within the constraints given. Okay, so that's about that. Then a few reasons, typical reasons for migration, which are good opportunities for efficient consolidation and to also to get some cost savings on your data platform and better grip on that. So one would be a data sprawl. You may end up having a server after server, system after system, application after application, a set of servers that may be from few tens to even like thousands. And it's basically just a good way to do the things that when you're having a new software, new system, new application, you just establish new virtual machine or a physical machine for that. But in the end of the days, you may end up having a situation wherein you pay a lot of overhead of your platform. It may be over 50%. This is because there is so much spare resources on your platform. So this would be a good situation to consolidate those many servers into a fewer bigger ones and see how to organize and reorchestrate the instances, databases, and remaining resources on storage size the most efficient way. Then another situation for us an opportunity to consolidation would be the cost savings. That's obvious. So for example, if you have a situation wherein you find out that okay, now the platform is growing much faster than what expected, and what is the amount of license to be used inside the company. So that's good spot also to make a move towards consolidation. Then company merger is of course a logical situation for that. Platform modernization, data center renewal and change are both situations when you would go for that. And of course the cloud transition. Still, if we are going to cloud, we are able to make, for example, consolidation against the IaaS, and even the smallest managed instances. That the newest one, I think it's now on 2 vCPUs. You still maybe end up having a situation where you can consolidate some of the long-tailed smallest instances into one, and so on. Okay. Then the next topic is that how the capacity planning affects the platform performance. So there are a few things to remember. In terms of CPU utilization, well, the newer CPU and the newer generations are the faster CPUs. And typically a new generation of CPUs is 20 to 40%, maybe averaging 25-30% faster than the old one. So it's no brainer that if you're having a few generations old servers, or even one generation older servers, you may end up having a wonderful situation for optimizing the number of CPU cores in total in your system, especially when consolidating. But you may need to still be aware of contention. So if you're having a content switching on CPUs, there is too much parallelization, too much things ongoing on CPU side. You should fix that problem inside the SQL Server before going to have a bigger CPU with lesser cores, even though it may be performing better in terms of benchmarks. But if you are going to reduce the number of cores and you already having contention, then you definitely have still contention problems in the new environment. Then one thing is also good to remember in terms of CPU utilization: do not over consolidate. For example, putting many critical instances under same host is a bit risky. Of course, when you have enough statistical data based for those decisions, it's okay, but still there is its limits on consolidation, and I will go through such example later on in my demo, so you can see what means, how we can control these risks. Then you should analyze both peaks and average workloads, because they have different trends. For example, peaking CPU can be very rarely occurring event, but the average CPU can still be relatively high, and or vice versa. So then also you should leave more computational reserve for mission critical servers. For example, if it's very mission critical server, you may not want to have a CPU utilization of peaking component over 60% in any case over the next 5 years, or 30% on average in any case. Or if it's less critical server, you can set the threshold values on a different level then. For example, 80 and 60% utilization. Then about RAM, it's also same thing. You should analyze peak components and average components. Of course, how the SQL Server uses the RAM, the peak is really the more relevant, because it gives anyway the result very similar to what comes to an average, but it's always more secure to have the kind of most how would I say, the most resource consuming counter there. And also leave enough memory reserve for mission critical servers and operating system. That's also same thing with CPU. You should use operating system reserve and virtualization reserve at some level. Then storage, you should take in account all the necessary performance counters, and these performance counters are such as latencies, IOPS, read-write total, then megabytes per second read-write total, and also log and data file sizes allocated and reserved. So all those are important in terms of capacity calculations. In addition to that, you should need to take in account some of the network parameters. So typically this is not an issue, but in bigger environments there may be some bottlenecks you have to take in account and kind of isolate certain host servers or certain templates of host server environments under those areas that have those bottlenecks or don't have those bottlenecks. And then also, if you are having instead of capacity planning based on the baselines on your system and hypothetical benchmarks on target environment, if you are using a benchmarking software such as HammerDB or something like that, then you should take in account also the query performance in general. And so also compare the performance counters before and after the migration, or before and after the benchmark if you are using such a software there. There is also, I would mention that the good idea if you're using a benchmark software would be to analyze the latencies to understand the regression between the SQL Server versions, if there are many versions like from 2006 to 2019 or something like this, a really big transition in terms of version, so it can make the regression to a performance. Okay, so that's about how capacity planning basically affects to platform performance. So then I would like to raise one topic that is very essential in capacity planning is the diagnostics and performance optimization. So there are a few things to consider. So I always say that if you don't make any kind of diagnostics on your environment, at its worst, it's crap out, crap in. That's because basically one rotten apple will contaminate all the good apples in the basket, or I think you say it that way in English. So in Finland we have this wonderful proverb that is, but you get the message. So if there is even one database, one instance, one performance counter on one server, anything instanceable configuration option, some funny index somewhere, or a stored procedure going wild every now and then, you may end up having lots of problems, especially when consolidating, because those wild queries or configuration settings or database options, whatever, can really make the consume too much resources on that side. So if you are going to make a diagnostics and performance optimization before the capacity planning, you will end up much better results in terms of savings as well. So that's why it's important. So you should inspect things like memory pressure, CPU contention, storage latencies, network throughput, things like that. And what you should also check is wage stats, plan cache, indexing performance, instance level configurations, and database options. And also track the most resource consuming queries. That would be a good set of going through different kind of stuff that can be wrong in your system. And did I mention the indexes? Maybe not. So of course, indexing is very important part of that journey. Okay, so then a little bit about Azure. I'm not going to tell about PaaS. It's only IaaS. So IaaS VMs are pretty much same as the on-prem VMs and servers. So basically they support fully all the SQL Server components, transactional replication, always on availability groups, integration, analysis and reporting services, log shipping and SQL Server backups. And there is different kinds of checklists to ensure and Microsoft best practices to ensure that you are having the optimal performance on your virtual machine if you're doing a lift and shift to Azure IaaS VM. So basically, if you're having Enterprise Edition, you should use DS3 V2 or higher virtual machine, and for the standard web editions, DS2 V2. And in terms of storage, you should use premium SSDs for production workloads, and standard storage is pretty much okay for development or test environment. But if you want to make such a test environment that you can also run the workload testing there to have relevant results, you should have premium SSDs there as well, because of course if the storage is on different tier, you definitely get the different results on in terms of performance. Then in terms of disk usage, so you should use basically minimum of 2 P30 disks, one for log, one for data files, including tempdb, but I would recommend to use also logs and data files different for the tempdb as well as the user databases. And for bigger workloads like requiring 50,000 IPS or more, you should consider using an Ultra SSD. Then you should avoid using operating system or temporary disks for database storage or logging. Enable read caching on disks hosting the data files and tempdb data files, and do not enable caching on disk hosting the log file. And then you can of course try multiple Azure data disks to get the increased I/O throughput, pretty much the same as in any RAID configuration on on-prem system. Then in terms of I/O, a few things still to remember when going to Azure VMs is to enable database row / page compression if relevant. You can test that. And enable instant file initialization, so same problem there as in on-prem. Limit auto growth of the database, disable auto shrink of the database, because otherwise you get problems to index start fragmented and the system file structure gets fragmented as well. Move all databases to data disks, including system databases. Actually, this is also quite many monitoring software are using heavily on master database and so on. So it's good idea also in that term that it's done so. Of course, otherwise as well. Then what else? Move SQL Server error logs and trace file directories to data disk. Set up default backup and database file location. That would be a good idea, and enable locked pages in order to prevent the spills on the slow disk, so to prevent the swapping, and apply for of course the SQL Server performance fixes. So pretty much the same stuff that you're going through when you're optimizing the basic performance of your SQL Server on-prem. Okay, so then I have a couple of demo use cases. So that's we are now in a middle of my presentation, so we go through about 25 minutes on these, and then a few minutes for questions in the end of this monologue here. So first about SQL Governor. So SQL Governor is our software that is SQL Server performance and capacity management software. And today we are focusing on purely on capacity management. So that's the part what we are going to use in the software. And the first use case that we are going to go through is the planning the consolidation of SQL Server instances from multiple servers into a single virtual machine in Azure Cloud. Now, the SQL Governor software is not actually doing the actual transition from on-prem to cloud, but it can show the capacity needs for any number of servers in a cloud in a way that, for example, if you are having 200 SQL servers in your source environment and you want to consolidate them all into Azure cloud, you can calculate that of certain sites virtual machines on Azure, if you're restacking the instances, what would be the optimal setup of restacking those instances on virtual machines in order to get the minimum number of Azure virtual machines of that size, and therefore, of course, not only saving money, but creating the most robust setup possible from that consolidation SEMA, so you may end up having a fewer number of target servers that you had in the beginning as source servers. So that's the point in there. Okay, and how it's done, the software uses machine learning for this particular task. So it takes in account all the hour series of peaking and average components on like CPU utilization, RAM utilization, lots of storage components, and so on. And it finds out the trend extrapolations and benchmark extrapolations between source and target servers to understand that how much capacity for desired scope of years we will need on that environment. So now I'm opening here this software, and as you can see, this is the monitoring view of the software currently here. And we have 4 servers here, GoDB Demo 1, SourceDB 1, 2, and 3. And all of these servers contain instances here, and these instances contain databases. So for example, SourceDB 2, I can drill down to that, see what's happening there, select certain individual instance there and see what's happening and what's going to happen in there in terms of monitoring. And then I'm going to see what's happening inside the database with certain performance counter and things like that. So that's just the basic monitoring here, but it's important. As you can see, it's in terms of hour series here, we can see the sampling is taken within 2-minute intervals. It can be controlled what is the sampling, but then the long-term data is being stored in 1 hour time series from even many years of time. So it's enough granularity for any kind of capacity planning purposes. And now when we are going to report side, we can see a heat map that is just to get a basic idea what is happening on these servers. So you see that average CPU consumption on the SourceDB2 is bit heated up, and also definitely CPU utilization, peaking utilization on monthly basis on SourceDB2 is as well quite high level. And we want to go to see the daily heat maps here. So I go here and I put this magnifying a little bit that we can see the whole time series here. Okay, so now you can see I flashed this log in 2 weeks ago, so we see the detailed data now in 2-minute interval calculations only for last 2 weeks. But here we can see that SourceDB2 has almost 100% utilization on every day in terms of hour series, and also the peaking, the average component is quite high. If we take a 5th day of October, that this seems to be the highest one, and see how the health of the server looked like on that particular day, we can say it's very bad news, because we can see that there has been data sampling interval on every hour that is going to peak to 100% and also the average workloads are very high. So it's no brainer that we should do something about this particular server. But in this case, we are actually doing the consolidation planning and capacity planning for all those 4 servers. So the next thing I'm going to do is that I'm going to show you metadata of the software. So the software collects metadata. For example, I magnify this a little, okay? So different kind of metadata. So we can go, for example, to see the exact servers here. And as you can see, I have created a list of models and server models and what particular CPU they are using. So this information can be actually adjusted in the software. So we have brought in all the specifications of like a Dell and IBM and HP and so on servers. So here we can select the desired hardware, and then we can see is it hyper-threaded or not, how many cores is it virtual machine, and how many host cores it uses. Then we have physical target servers here, and these physical target servers are the ones that if we are going to create the target consolidation servers, we need to create these servers, and we can select how many cores, what is the amount of RAM, how many operating system cores, what is the operating system RAM reserve, and things like that. And then derived from the host pools, we can create the virtual target servers, wherein we can tell also the setups for these virtual machines. But now we don't have to create those physical target servers and virtual target servers templates, because we have Azure templates already filled in our system. So next thing I'm going to do is I'm creating a planning solution here. Let's create a new solution here and give it the name demo. Oh, I'm so creative. And then drag and drop these servers into this project, and we have selected actually all the instances to be marked as under the migration. So we just select include instance mark for migration. Then we select the planning scope. We want to plan this environment for next 3 years. We want to take the statistics data that is calculations are based from beginning of July until beginning of October. So 3 consecutive months, that's pretty much the minimum when you want to do this more exact, and it's good to have the peaking periods over the seasonal peaks on that particular period there. Then we save the solution. We take the new project, then give it the name demo project. And this is actually virtual machine fit mode. It means that if you're going to have a physical host that is using virtual machines, so you can set that if it's a failover clustered instance, is the failover occurring from physical host to another or inside a physical host. So we actually can put it, for example, compact, because we are using now the Azure virtual machine. So we take a mix of Azure from here, and then we can actually select standard G5. This is 32 CPU virtual machine, and what we can do here is we can set now this is the target template. So this template generates as many virtual machines as needed per minimum for all those instances that I'm going to drag for this template. So the max fill level for average CPU, let's say that the 50% is good to go. Then peak CPU 80%, that's fine. Average RAM 80%, that is also fine for us. SLA for average CPU, let's give it 99.9%, and average SLA for peaking CPU 99.9%. So every 1 hour out of 1,000 hours can exceed that those given threshold points. So I can control that on calculations here. Otherwise, it's not going to accept this calculations. And then I can set like server type, is it active, passive, standalone, FCI setup, and if there is a planning group. Well, I'm not going to create any type of planning group there because we can have different kind of planning groups. That's also important in capacity planning. So you can say these are test, this is development, these servers are for products, and this is 2008, 2016, 2019, so on. And now I'm good to go. I save this. And now we go to actual planning mapping. And here I'm now in the machine learning area of the software where all the magical things happen. I select the demo, and here the demo project. And here I can see now that there is this G5 with all the constraints I gave for the algorithm, and the scenario count index I put to 1 because I don't need that high level of index here in machine learning because there is just a limited set of servers, and I think that they all are going to fit anyway on this particular server. If there was like tens or hundreds of servers, then this template would generate as many servers as needed per minimum, as I told earlier on. So now I'm good to go, and I can just select these servers and drag and drop them to their corresponding template. And now I click process. And now the software starts to calculate the capacity distribution for that Azure virtual machine. And now it's calculating. It should not take that much time. Okay, now we have the results here, and I can view the results as a diagram. And here you can see all the instances fit into one Azure GS5 server. And here you have the summary that 56 cores ended up to 32 cores on Azure. And what is more interesting, we can go back to reports. I put this a bit bigger once again so we can see, and we go to planning results, and now we can see actually the capacity calculations. We can see all the IOPS and data needs, latencies, things like that. Okay, we see that there is quite a latency. If I was a DBA, I was happy with this result and this result, somehow satisfied with this result, a bit of question about these, and really losing my hope with these ones. But as I say, this is our demo environment, so it's by all means it's shown up here like that. Then we have average CPU usage here in terms of resource extrapolation over time, and also how the peak CPU usage is behaving over time. And we can use, instead of daily granularity, we can go to hourly granularity. This takes let's say about 10 seconds before it calculates those all the time points for this visualization. But then we see more details on how the instances are stacked over time over this forecasted three years of time there. Okay, here is how they behave, we can see. And RAM usage is just almost nothing, like on few percent level. So that's instance level consolidation, and we would be able also to compare results after the instance level consolidation. We would be able to go to a migrated instance comparison report, and here we would be able to select that, okay, the name of the instance as server was first dev 12 on source DB2, take all the performance counters here, well, at least CPU usage, IO busy, disk reads write, buffer cache hit ratio is interesting. Maybe also latch and batch. And then I want to take source DB2, and it was changed as a dev 14, and we take September 2018 as a comparison point. So the point here is that we could, okay, this is not the real case now, but the point is just here taken, that you can see that there is these two instances and you can compare how they evolve over time. And that makes easy to understand the comparison before and after the migration. Now, next thing that I'm going to show is planning the consolidation of multiple SQL servers into a single host pool in on-premise virtual platform. So now we are using on-premise virtual machines and we are consolidating on server level. That's also what can be done with SQL governance software. So I'm going to right sizing, and here I'm going to create a new project. You can see that these are the servers, their corresponding integer benchmarks. We use spec.org benchmarks. If you were thinking that where we did get that calculations of host and target server ratios, we have filled in all the benchmarks of spec.org here, and we update on regular basis on these values here. So now I give a name demo 1 and then I give it 3 years of time once again and select July 1st until October 1st as well, and I save it. And now I can select what kind of host I'm going to use. The pool I'm going to derive is from R940, and I just use the default pool basically there, and I select similar CPU than in our example 32 cores CPU, and also here I'm going to select the average CPU 50%. That's the threshold point for that. Peak 80%, 90%. Let's put the same to 80%. Average RAM. SLA is the same, 99.9. We want 3 nines for this. Okay, now it has its trip nines here, and then we get the operating system reserve 1 core and 10 gigabytes for RAM. And now we're good to go. I take a first server and take its workload, and now it's extrapolated over 3 years of time with those ratios of benchmarks. We still have space. We take another server there, then another, and now they are created as virtual machines. Not actually created, but planned as virtual machines here. And now I have the last one, and now I can see the hourly values here. And we can see that it all fit very nicely here. There is not much RAM consumption at all, and the peaking CPU and average CPU consumption is just fine. Now I click save, and actually here when I clicked save, it starts to calculate the storage space for all the databases on that particular server setup here. It takes some time, about 30 seconds or so, still maybe 20 seconds. This is a bit slow machine that I'm using here, but it takes some time. And when it calculates those, it's very similar to instance level consolidation. Of course, there is no machine learning in this server level consolidation because this is so-called semi-automated process, but still it's very nice because you can see the results immediately and see how the servers will behave under that host. And now you can go back to that host and see the right sizing results. And now we have here this project demo 1, and we can see that we had 4 servers. Now we have only 1 host server, from 56 cores to 32 cores. And this is the important thing here. SLAs are perfect, and the right sized virtual machines are planned already here. 3 cores here, 9 cores there, 10, 9, totaling 31 plus that operating system reserve 1 core that I left there. And there we can see also the IOPS needs that can be drilled down into an individual database level, and then I have here peaking CPU, average CPU usage, and RAM usage as well. Okay, so that was the demo of how easy it's to plan the capacity for the virtualized environment. And now the last, not the last demo, sorry, before that, the comparing the results. As you saw, the instance level consolidation, it was quite easy to do, and there was relevant reserve still on those servers from 56 to 32 cores. This is quite typical. We have average 44% savings with our software on consolidation cases. Of course, that can vary on case basis, but that's what we have average on our cases. And this is typically most effective in terms of saving this instance level consolidation, but it cannot adapt to SQL Server services. So if you have integration services, analysis services, reporting services, so on. But serverless consolidation, it adapts to those any kind of SQL Server workloads because it takes all the footprint of the whole server, and typically the results are not that big in terms of saving, but it's a very nice way to do the consolidation as well. Then the last demo is we have actually savings calculator on our page, www.sqlgovernor.com/calculator. I go to calculator now, and here we can see that if you have, for example, let's say you have 50 servers, enterprise licensing is, for example, let's say 13.5 kilos, then 13,500, and then you have software assurance price of 6,000 and standard license price 3,500, software assurance price per year 1.6 thousand, and amount of enterprise and edition and standard edition is 50/50. So then amount of SA of all licenses, you have SA in every license. And you can calculate what it would cost if you would make the consolidation on average. What would be the savings potential in your current environment with these 50 servers, with these parameters? And we get the result of $800,000 potential of savings over 3 years. So that's an easy way to see that what would be the average potential in your particular environment if you would go to consolidate that environment. And as you can see, the point of consolidation, either you do it with software or if you do it manually, it's about understanding different kind of workloads and pointing different kind of threshold points for those workloads on target servers to get the right level of resource utilization. So the more critical ones, not that much resource utilization. The lesser critical ones, you can have more resource utilization. So that's the point there. Okay, and then I go back to this presentation here, and this is actually the last slide of my presentation. Thank you very much, and I hope that this was fruitful for you in some level, and I had some valuable information. So any questions you would like to ask?
We did have one question that I'm sure a lot of people are asking themselves. Yes, this is recorded, and we will be putting it up on YouTube as well as other places. So stay tuned to our social media so you can get the link to watch it on your own time and refer back to it. I'm not seeing any other questions come in. If you do have any, please feel free to reach out to Yanni and his team at that email address you see on the screen. And we look forward to having you guys at our next webinar. Thank you all for coming, and have a great day.
Have a great day. Thank you.